Hello guys, welcome to my slideshow. Today, I'm going to present to you episode 2 out of 14 other episodes, and we're going to review fractions, decimals, PEMDAS, and rational numbers. So let's start without wasting no time. Fractions, part 1. Fractions are a big step to decimals, percentages, and ratios, and lots of other. But first, before we do anything, we need an example and what is a fraction. A fraction is a part of a whole. So jot this down. A fraction is part of a whole. And I'm not saying it has to not be a whole. It can be a whole too, but it's also can be a part. And here's an example. Let's say we did number lines, guys. 1, 2, 3. And we had 1, 2, 3, 4, 5. But do you always wonder what's between them? Can it be a whole number? No, it has to be a fraction. That's what a fraction is. It can be presented in many ways, but right now we're going to focus on this. We're going to do operations with fractions. For example, addition. Guys, let me guess. This is what you're going to do. No, don't even think about it, guys. That is the worst idea. You have to have equal denominators. And by the way, a denominator is on the bottom and the numerator is on the top. And this basically means 1 divided by 4. So we could say 4 is the divisor and 1 is the dividend. So numerator is dividend and divisor is denominator, like we learned in our last episode. So let's make this more sense to you. We have a circle, not a perfect one. We have lines, 8 different pieces, and we covered 3 so far, and we want to add 1/4 of it. So do we just add more pieces? No, that's the total number of pieces we have. So if I ate 3 pieces and somebody else ate 1/4 of the whole thing, we need to find 1/4 of 8. And that's gonna get tricky unless you have the same denominator. But how do you get the same denominator? Here's a trick I like to do. Scale methoding or multiply by itself. But right now, the easiest way to do is scale. So because we know 4 times 2 is 8. So you have to do whatever you do here, you do over here. Because 1 times 2. And you'll get 2 eighths plus 3 eighths. And that makes 5 eighths. The reason why I didn't change the denominator is because where did we get more pieces from? We have 8 total, not 16. And this is how it looks like on a pie chart. I ate 3 pieces out of 8, and I ate 2 pieces out of 8. And that means we have 1, 2, 3, 4, 5 out of 8. And that makes 5 eighths. Good. Now let's go to subtraction. Subtraction, same thing, but you subtract. But this one shows it in a different way. What if you got this? 5, 6 minus 3/4. You cannot scale, and you cannot divide, so you have to multiply. For example, we can multiply by each other, or we could find something That's equal, like 6 times 2 is 12, and 4 times 3 is 12. So we could do 3 times 3, which makes 9 twelfths, plus 5 twelfths, minus. Or we could do it a different way, a easy way. Multiply by each other. Because that'll always make it the same denominator. So we have to multiply 4 to 6. Sorry guys. 4 to 6. So same thing here. You have to multiply 4 to 5, 4 to 5. And you will get 24. And how do you make... Now, I will have to multiply 6 to 4. So which make 24, and 6 times 3 is 18. Then you subtract. You get 24, 2. And I will want you to simplify this, because this is a big fat number. And who would want to say there's 2/24 of a piece? Too much. So you have to simplify, which means make it shorter or reduce. But this one we didn't have to, because we can't divide them by the same number to still have a whole number. But we could do this one, divide by 1 or 2, because if you do it by 1, you get the same number. Divide by 2, and you'll get 1/4. Same thing. So same thing here. We can divide any number by these two. So can we divide 1? Yes, but that'll get the same number. But if we get 2, you'll get 1/12. But if we try 3, we can do 3 on this, but not on this. So we can't do that. So just pick the closest one. This is your best choice. Okay? And that's how to subtraction. Multiplication, to be honest, I feel like this is the easiest operation. Because look, 3/4 times 4/5. All you do is just multiply. 3 times 4, 12. 4 times 5, 20. Remember to reduce that or simplify. We can both divide them by 4. And that'll get 3/5. And can we divide them by anything? Yes, but that'll become a decimal. We don't want that fraction. And division, it's gonna be pretty hard as long as you remember this technique. Copy, dot, flip. So what this means is if you got an equation like this, 4/5 divided by 5/6, you have to copy, which makes 4/5. I'll write that over here. 4/5. Change that division sign to multiplication, which means dot, and you flip the numerator and the denominator, which makes 6/5. Then you multiply 4 times 6, 24. 5 times 5, 25. And then, can you simplify that? No. So you got 24, 25. Since division's a little harder, we can do one more example, guys. Let's say we got 6 tenths divided by 1/5. Copy that. 6 tenths. Change that to multiplication. 5, 1. 6 times 5, 30. 10 times 1, 10. And that simplifies to 3, 1. And guys, I really want to tell you this. This is simplified to 3. Since this means if I got one cookie and I want to make 3 other cookies. I basically beat this 3 times. So I got 3 extra. Or not extra, but 3 wholes. If you got 8 16s, how do you know how many times it went to? Subtract. 16 minus 8 is 2 times. So it passes 8 2 times. If you got, let's say, 25, 8, you're gonna need to subtract that and you'll get, it'll go 3 times with 1 left over. And that will become a whole number, which we're gonna learn on the next slide. Congratulations on passing your fractions part 1 course. Now we're gonna move on to our next slide. Fractions part 2, mixed and improper. So, if I were to add this, I got 12 eighths. This is called an improper fraction, because this is more than the denominator. To make it mixed, 12 minus 8, it goes into 1 time with 4 left over. And 1 4 8, 4 8 simplifies to 1/2, and you got 1 1/2. Very easy, guys, right? Yep, that's all you do. Let's do one more example. Let's quiz you. 14 tenths, 1 1/8, 0, 16, 16. 14 over 10 is improper. 1 over 1/8 is mixed. 0 is mixed since it's in its position. 16 over 16 is improper because it has to be 1, not as a fraction. Congratulations on passing your fractions part 2, mixed and improper. Fractions 3/4. Fraction into a decimal. So if they were asking you, I had to pay $3 and and I had to take that away from 4 people, what you'll get. This is how you do it. Write this definition. To turn a fraction into a decimal, you have to put the numerator in the dividend section while the denominator in the divisor section. Then you divide, but instead of leaving the remainder, you are going to put a decimal point that looks like this and add a 0 to divide with the divisor. After that, if it still has a remainder, then keep adding a 0 and until it stops or repeats. Here's a picture. So for example here, 4 goes into 1 0 times, but then we couldn't see this. But we have no more left. So I answer 0. No, you put a decimal point and you add 1 and 0. And you get 8, since 4 times 2 is 8. Subtract that by 2, and then you add another 0. You can add as many zeros as you want since it's a decimal. And then you keep going until it reaches to 0. So add it 4 divided by 1, 0. 4 divided by 10, 2. Subtract the 8, 2. Put a 0 there. 4 goes into that 5 times, and that's your answer. Same thing here. 3/4 turn into 4. Has to divide 3 and separate 3. And you get 0.75. Well, let's quiz you right now. Simplify this as a decimal. Pause the video if needed. Good, you're right. You do 3, 8. 8 goes into that 0 times decimal point. Add as much zeros as you needed. That goes in there 3 times. 24 minus that, 6. Add a 0. 8 goes to 64. Let's say about 7 times. 56 minus that, 4. Put the 0. 8 goes into 40 perfectly 5 times. And that's your answer. 0.375. And that is your answer. Congratulations on passing your fractions part 3, fraction into a decimal. Now we can move on to our next slide, which is called repeating decimals. What are repeating decimals? Jot this down. Sometimes when decimals are being converted by a fraction, it can become a repeating decimal. This means you'll keep on adding zeros forever. But how does the person know if the decimal repeats? For example, if the decimal is 1.17, you would just need to put sorry guys, I got lost. You would need to just write the repeating numbers and straight line on the top like this. 0.17. But it has this, which makes it repeating, so we know that. Another example is instead of 0.65478, 0.65478, do this. 0.65478 repeating. And it will look like this. For example, I want to find this. 3 goes into 1 0 times, 3 goes into 10 9 times, 3 times, you have 9 left. And you notice it repeats. So that's why you're going to have to put the number that's repeating, and that's your answer. So you can also represent this as 0.3, or, sorry guys, you can represent it as 0.3 or 0.3. Doesn't matter. Congratulations on passing your repeating decimals course. Now let's move on to, we're going to do operations with decimals. Decimals are the same thing as fractions, part of a whole. And it can also be a whole. Like 1.0 is basically 1. And before we go to ending, let's practice the place value. So if you got 111.1111, so this is the thousands, this is the hundreds, this is the tens, and this is the ones. This is the 10. Instead of tens, it's tenths. This is 100 with this thing. So the difference basically below these type of numbers have THS, and the numbers over here have DS. Just remember that. So let's get off with addition. Addition, always line up the decimal point. This is not how you do it. 18.17. 7. Let's do 1.1. Don't do this. The decimals have to be lined up. So if you were to got I'm going to simply review this example. They got this 8.20, sorry guys, 8.2, 0.03, and they got 0.004. That's uneven, right? That's all. You can just add an extra 0 if needed, but you don't need to. It's just going to be 4 plus nothing, which is 4. And continue. 3, 2, bring the decimal down, 8, 1. And you basically got 18.234. All you do. That's all you do, guys. Now, subtraction, same thing. 7.58, 0.265 minus 5, 5 minus nothing. Can't do that. So you have to add a placeholder, which is 7, 10, 10 minus 5, 5, 7 minus 6, 1, 5 minus 2, 3, decimal point, 7. And you got 7.315, 7.315. All you do, multiplication. I got 7.04 times. Don't forget, just don't worry about the decimal placing. Just put it any way you want. And just forget about the decimals. Just do 0.4 times 32. And you will get 22528. And then you need the decimal. Because over here, look the decimal. Count how many decimals, how many numbers are behind the decimal. 1, 2, 3. So there's 3 numbers behind. So that's how many times you're going to move the decimal. 1, 2, 3. And then you are going to get this very beautiful number. Division hardest is going to look like this. So first thing first, 4.2 divided by 21.84. You cannot have a decimal outside. And that'll turn to 42. Whatever you do here, do the same thing here. And now you got 42.218.4. Then divide normally. Just bring the decimal point up, divide. And since you already have a decimal point, you don't have to add another one. And you eventually get 5.2. All you do, guys. Congratulations on passing your operations with decimals. Now let's move on to our next slide, which is estimating. To be honest, I feel like estimating is easier than everything we did, but let's practice. So what if you got this super big 8817 there, and they asked you to estimate. And now if we go back to our math symbols over here, we're going to use this one, similar to, or estimated to. So which means, if I got 2.8, I'm going to round this or estimate it. For example, if you read this, if you break this in half, and the number behind it, if it's 5 or more, let it soar, which means that the whole number become bigger, 1 bigger, 3. 4 less, let it rest. So if it was to be this, you just leave it as 5. So this is how you be. Like, the answer is estimated to, this is how I write estimated to, 3. and answer equals 2.8, and answer doesn't equal anything that's not these. And if you were to add this, 2.8 plus 5.1 equals 7.9. That's the exact answer, but you could either estimate these and add, or just estimate the answer. I recommend you to estimate the answer because that's easier. Now let's quiz you. 5.716. I asked you to round the hundreds. And where are the hundreds? Over here. Because tens, hundreds. And that's zero. So just let it rest and you got 5.7. That's how you do it. Congratulations on passing your estimate course. Now let's move on to the next slide, which is PEMDAS, which simplifies to P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. The reason why PEMDAS is so useful is because of this. If you got this giant equation, what do you do first? What do you do next? This is the order of operations and how you do it. Just remember the word PEMDAS. PEMDAS. Parentheses, exponents, multiplication, division, addition, and subtraction. So, first thing, parentheses, which means we have to solve the equation in the parentheses. 2 plus 3, that makes 5. So this turns into 100 divided by 4 times 5. What's next? Exponents. Do we have any exponents? Nope. Do we have any multiplication? Yes. 4 times 5 is 100 divided by 20. And do we have division? Yes. And this makes 5. So the answer for this would be 5. You did not finish this course yet because we're going to focus on another slide which has other stuff you need to know. Brackets, braces, and more. So if you were to get this, 2 bracket, braces, parentheses, stop right there. That's big. So let's see how they do it here. If you got this over here, first solve the parentheses, then the brackets, next the braces. So first, 10 minus 9, that makes 1. And you have to do the bracket one next. So 2 plus 1, 3. So this changes to 3. And then you have to do the braces next, which is 18 minus 13 minus 3. And you can make your own. So let's do the big ones first. 18 minus 3, 13, which is 5 minus 3. And that makes 2. So your answer for this would be 2. But what if you got this? Let's calm down for a bit. 2 braces 50 minus bracket. Now let's stop right there. Solve the parentheses first. And you got 24, which makes it parentheses first. 24 plus 10. Do the bracket. And you get 250 minus 34. And if you use PEMDAS, you notice that you have to do multiplication first. But these are braces. So you have to do the braces first. Which is 50 minus 34, 16. And 2 times 16, 32. That's how you do it. Got that? So, congratulations on passing Order of Operations, also known as PEMDAS. Now, let's move on to rational numbers. and integers. First, what are integers? Integers are positive whole numbers, negative whole numbers, and it could be a zero. It cannot be a fraction, it cannot be a decimal. Rational numbers can be positive whole numbers, negative whole numbers, zero, fractions, and decimals. But rational numbers cannot be unpredictable stuff like pi. That has so many numbers. It's unpredictable. 8. We can't predict that. This. We can't predict that. That has a negative here. This. We don't know what's next. Those ain't rational numbers. Got that? So that is the simple meaning of rational numbers and integers. But we're going to get into higher levels of rationality when we get to more episodes. But right now, I just want you to know this. A rational number has to terminate or repeat. And these make sense. Because we know that 0.21 repeating is going to end up to be 21, 21, 21, 21, like that. So, I congratulate you for passing the whole episode plus rational numbers and integers. Congratulations! See you on your next episode. I hope this helped you a lot. Please comment if this really helped you. Please subscribe for more notifications. Thank you guys. Bye.